We've all seen animals with forward-facing eyes, and we've seen animals with eyes that are facing more sideways. But one group of mammals evolved something much weirder. They can see directly behind themselves, not by turning around, but because evolution reshaped their skulls to exploit a really cool quirk in their vision. In this episode, we're going to find out how eye position decides what an animal can see, and why rabbits and hares might just have one of the weirdest visual systems of any mammal. Dr. Rex here. Welcome to the Skullywag Lab, where I break down the bare bones basics of skull science. Have you noticed how the skulls of different animals have their orbits or eye sockets facing in different directions? Well, for the skull nerds that we are, there's important information to be gained there, because the direction an animal's eye sockets face determines how much of the world it can see. The amount of the world an animal can see is called its field of view, and the kind of field of view an animal has provides some indication of how an animal lives. Let's take a look at some different animals and what their eye orientation means for their survival and lifestyle. Okay, so there's a bit of a trade-off that's immediately obvious when it comes to where the eyes of most animals are facing. More forward-facing eyes tend to offer an overlap of visual fields. This is known as binocular vision. Because both eyes are looking at the same thing, the brain can compare the two images to estimate distance and create depth perception. We most often see this in predatory animals, and of course, in primates as well. The reason for this in predators is pretty straightforward. And that is that they can better hone in on the 3D position of their prey. The story is a bit more complicated for primates, and to be honest, that could probably take a whole episode in itself. But suggested evolutionary drivers of this feature include nocturnal light capture and insect predation, leaping between and grasping branches while moving through the trees, fruit foraging, and seeing through obstacles in densely packed environments. More laterally facing eyes sacrifice some of that overlap for binocular vision, but in return they gain a much wider panoramic view of the world. They can see more of their surroundings, just with less depth perception from the world directly in front of them. This is better for animals that need heightened awareness, especially for detecting predators. Here's a nice image that shows the full continuum of orbit orientation across different animals. We can see animals like humans and predatory cats have almost parallel forward-facing eyes, while squirrels and rabbits have eyes facing pretty much straight sideways on their head. But it's not only forwards and sideways. What about upwards and downwards? Are there any animals with fields of view that are facing more upwards or more downwards? Yes, there are. Animals like rabbits have some binocular field of view aiming towards the sky, while something like a horse has some of their binocular field of view facing more downwards. As a more extreme case of this, just check out the downward-facing orbits on this skull of a giraffe. Most things a giraffe needs to pay attention to are going to be below eye level. A downward-directed field of view makes a lot of sense for a tall animal like this. Okay, so that's forwards, sideways, upwards, and downwards, but what about backwards? Just how far backwards can an animal see? Eyes facing completely backwards all the time would probably have too many negative effects to be seen in many animals. But one place that seeing right behind you might be quite valuable is in open environments where you might find yourself being chased by a speedy, agile pursuit predator. And it's in environments like this that we can find an extreme case of posterior vision. That's right, some hares appear to have evolved overlapping fields of view directly behind their heads. And it appears to stem from an interesting reflex seen in rabbits and hares that controls the movement of their eyes. Whenever the head moves, the eyes automatically rotate to compensate, and it goes something like this. When the heads of rabbits and hares are in like a horizontal position, they actually have some binocular vision towards the front of their faces. But when they pitch their heads forwards, that's like rolling their heads forward in a nodding motion, their eyes don't follow the same path. They counter-rotate to keep the horizon level, but they also diverge slightly, pointing farther away from each other. The binocular field shrinks and the posterior field expands. At first this seems like just a simple and necessary movement of the eye. Lower the head and the eyes rotate to expand the field of view. But this new study by Brian Kratz and co-authors suggests something a bit more interesting. In this study, they suggest that evolution reshaped the skull to amplify the effects of this reflex. Species with more downward tilted faces also evolve more outward facing eye sockets. Those two effects work together to create an almost 360-degree field of view, including some binocular vision towards the back of the head. If so, this would allow a rabbit to more effectively sense where danger is and keep track of it as it runs to safety. As far as we know, there isn't anything else quite like this in any other groups of mammals, but it does appear to quite closely resemble the weird skulls of the American woodcock. The woodcock has eyes that are positioned extremely far back in its skull, giving it an almost panoramic field of view, even when its bill is buried in the soil. You could almost think of it as like a lighthouse sitting on top of its neck, able to sweep almost the entire horizon for danger. For years now, we've described skulls as having eyes that are facing more forward or facing more sideways, but as you can see, there's a bit more to it than that. The skulls of rabbits and hares remind us that you can't always pigeonhole different animals into these clear-cut categories. In this case, evolution took an existing reflex and turned it into something that's pretty unique. I, for one, look forward to more studies on looking backward. If you enjoyed this content, leave a like and subscribe, and I'll catch you in the next one.